Welcome. We're going to look at graphing various functions, and we'll start off with some of the things that everyone has seen to this point. So, for instance, first is a constant function, such as f of x equals 3, which we're used to seeing as y equals 3. That would be a function because it's where y is equal to 3 at every point along that line, horizontal line. The opposite of that, vertical lines such as x equals 3 are not functions. Relations, yes, but here the single x of 3 has numerous y values, and of course you can't have that for a function. Each x value has to have one y value with it. So linear equations. You're used to seeing y equals mx plus b, when actually the parent function of that is y equals x. So you have the basic y equals x, and then the slope and the y-intercept at just that, moving it up or down, or adjusting the slope higher or lower. But it's a linear equation still, as long as the y and the x both have exponents of 1. A quadratic you're used to as a parabola shape, and a cubic you're used to seeing in an S-type shape such as that. And you have done the square root and absolute value type ones before, and these are always in a V shape. Different transformations will change how they look, but they still have the basic shape with them. We're going to look at doing an absolute value equation today, and we're also going to look at greatest integer and piecewise functions. These are newer ones, and these we will look in the next couple of pages. So we'll go through those types. And this one will be using this symbolism, the double brackets. And here for piecewise, it's a function that's in parts, and we have to write out the different equations that go with it. So first, let's start with an absolute value, the basic absolute value, the parent function. So the easiest way to graph these is to do an XY type table and find the vertex first. You find the vertex by taking what's inside the absolute value and making it equal to 0. So in this case, x is equal to 0. There's nothing to adjust it. So we'll put 0 in the middle here of our table. And then we have to determine if we put that x in as 0, okay, then that means our y value, the function of 0, is equal to the absolute value of 0, which is equal to 0. So 0, 0 is our vertex. So right here in the center. Now let's go up a couple of points, 1 and 2, and down a couple of points. So the absolute value of 1 is going to be a 1. The absolute value of 2 is going to be a 2. The absolute value of negative 1 will be a 1, and the absolute value of negative 2 is a positive 2. So that means we'll look at 1, 1, and 2, 2, negative 1, 1, and negative 2, 2. And now you can see that you're going to get a V shape here. Okay. Well, good enough of a line for now. That's the basic parent function of absolute value functions. Here is one where there are some transformations. Now you can take the parent function and change it with the transformations, because that plus 3 will move everything over 3 spaces. Minus 1 will make everything down 1, and the 2 will constrict it in size, so it'll be slimmer or thinner. I think it is also very possible and easy to do a table of values for it. But once again, now we have to take what's inside the absolute value and make it equal to 0. So negative 3 will go in the middle. And then I'll determine what would happen. Negative 3 plus 3 minus 1. That's going to be 2 times the absolute value of 0. Well, the absolute value of 0 is 0. So 0 times 2 is 0. And so we get minus 1 to match the negative 3. That will be the vertex of this absolute value. So let's go to -3 and -1 and put a point there. Now I'm going to go up a couple, -2, or actually down, and then -4, -5. Yeah, no, that was up and then now down. And so let's determine what happens here. If I put -1 into here, I get 2. 3 take away 1 is 2, minus 1. Well, the absolute value of 2 is 2, so it's 4 minus 1, we get a 3. When I put -2 in here, I get 1. And 2 times 1 is 1, minus 1, we're going to be at 0. I'm going to go to -1, 3, and -2. Something off. Hold on, let me check my numbers here, because this should be a straight line, and one of my ways of checking here is why isn't it a straight line? So let's go back and check these numbers. So if I put -1 here, I see what happened. I did not actually work that one out. So let's take this one and work it out better. 2, -1 plus 3. So 2, 2 minus 1, that's 4 minus 1. No, that comes out to 3. And then here, when I put -2 in there, I get 2, take away 1. That's my error there. So in this case, this is 2 minus 1, which means it's a 1. Good. Now, that means I can fix this one and put it at -2 and 1. And now I have what would be a straight line going up this way. But I have to do these other numbers. I cannot assume that it keeps going this way, because I know that if it's an absolute value of any type, it's always going to have some kind of V shape. It might be going down, it might be going really wide, but it's always going to have a V shape. So I know that I have to keep going until I find where it changes. Well, I know it should change right here. So let's see what happens with the -4. I'll put this one in black down here. 2, -4 plus 3 minus 1. Well, -4 plus 3 is a -1, but -1 absolute value is 1, so we have 2 times 1 minus 1, which is 2 minus 1, which is 1. And then the other one, 2, -5 plus 3 minus 1, that's -2. But -2, absolute value of -2 is 2, so 2 times 2 is 4, so it's 4 minus 1, so that's a 3. So -4 and 1, -5 and 3, and it becomes like the mirror image of the right side line. And let's erase this, since those are not where it was going to go. I thought maybe, but no, it doesn't. It changes at the vertex here. And that would be an absolute value that's not at 0, 0. And the key there is to use this to determine what your starting point is, and then go up and down from there.